Hello and welcome everyone. In this day 34 learning, we have previously covered merge sort and quick sort. In this session, we are going to be looking at shell sort, heap sort, and linear sorting algorithms such as counting sort, bucket sort, and radix sort. Firstly, let's start off with shell sort. So, so shell sort can be thought about having to compare elements at a gap size and then sort them similar to insertion sort. Like, for example, let's take an example. And so let's say we have an array of 23, 12, 1, 8, 34, 54, 2, and 3. Let's consider this as an array. So there would be a gap which would be equivalent to length by 2. So initially, like let's say gap is 4. So we compare elements at this position to this position and this one to this one. Similarly, these two here and finally these two. So out of all of these, we see that uh, only these two positions can be swapped. So after gap gap 4, we get a result of 23, 12, 1, 3, 34, 54, 2, and 8. So this is the value, right? So once this is done, we again further divide gap by 2 at step 2, gap to step 2. So this time we compare these two elements, and then again we have these set of elements which get compared again with the previous values also. Like, for example, these two get compared and these two get compared, and also with the previous set of values if there is swaps. So so let's say we have 23, 1, 34, and 2 as one group. And next we have 12, 3, 50, 34, and uh, 23, 1, 34, 2, right? So 12, 3, and this should be 54 and 8. So those are two groups. So we get we need to sort this group out, like comparing these two elements, where this would get sorted to uh, something like 1, 2, 23, and 34, while this one ends up with second group ends up with something like 3, 8, 12, 54, right? So yeah, so we get these two groups, say these in one array and this one in array. Now we need to combine both groups back, like 1 and 3 and 2, 8, 23, 12, 34, 54. So this is our final array after gap 2. After gap 2, gap 2. Now in gap 1, we compare all of these elements adjacent to each other, right? Like we compare 1 and 3 and 3 and 2, and similarly we compare all of these, all of these, all of these, all of these, and keep sorting it, right? So first we check 1 and 3. 1 is less than 3, so we do not do anything. And 3 and 2, 2 is less, so we obviously swap them, which would lead to 1, 2, 3, 8, 23, 12, 34, 54, right? So that's the value. And next we see these two values are lower, right? So these two values also will be swapped. 23, 34, 54. This would complete the sorting of this array. So that's the whole idea. So the way that the code would be implemented is, uh, we would be having a while loop which say a gap starts at length by 2 and gap greater than 0, and every time the gap gets reduced to uh, gap reduced to half of the previous value, like somewhere around here we also need to gap by 2, and here I initially will be at gap and I is less than n and I plus plus. It keeps incrementing, and we would also be having an um, j value, let's say at I, and we take j greater than gap, greater than or equal to gap, and we check array of I minus j is greater than a of I. Um, this should be a of gap, meaning it would be minus the gap. Like let's say if we are at the mid of the array, then we subtract I minus gap, which would give us like a zeroth position or an previous alternating gap position. So that's the whole idea that we are doing here, right? So and then we simply swap array of j with array of j minus gap. We swap these two and j to j minus gap. So that's the whole idea. Okay, so it would look something like this. Let me just quickly switch to JSBin editor and I will walk through the code snippet, which would here gap is equals to gap by 2, right? So there are 3 while loops, 1, 1, 1. Okay, so let me switch to JSBin editor and let's quickly look at the code implementation. So here I have shell sort, initially defined with gap, and gap we check till it's greater than 0. So initially we set I to gap, that is mid, and then we check the value of values alternating or the previous to the gap difference, and if it is greater than array of I, then we swap these two values out and also decrement j to gap. So array of j is equals to, right? So that's the whole idea. And if you see, the way that this happens is an in place sorting, and this would not be a stable kind of sorting. We do not need any additional memory is what we see, right? So time complexity is often, and best case complexity is n log n, because we are every time having to solve it by a length of length divided by 2, like the number of iteration gets reduced, right, drastically, right? So I've already run this example here, so that's shell sort. Let's go to the next one, heap sort using a min heap, right? So let me quickly switch to open board, new page. Okay, let's understand uh, heap sort. So let's take an example of an input array such as 4, 10, 3, 5, 1. So once we get this converted to an tree diagram, so let's say this would be like something like 4, 10, 3, 5, 1, right? Something like this. Consider it this way. So once we build a min heap out of this, min heap out of this heap one, so it would be like 1, would be like 1, 4, 3, 5, and 10. So once we min heapify, so this would end up in this array, which is nothing but the first value in our array. So we can simply pop this value out and keep this as a result of first one. Then again, we once we pop it out, we get 3, 4, 5, and 10. So again, we can keep popping this one. Step 2, we get 1, 3, and this would give us 4, 10, and 5, and 10. 5 and 10, eventually all of these will be popped out to form, would lead us to uh, 1, 3, 4, 5, and 10. This would result us this way. So there are two ways to solve an in and heap sort, either to apply have a uh, min heap or max heap. So I have built a code for uh, heap. So yeah, so I have built a code for min heap, and I will switch to the JS bin. Just understand the code structure, even though this is not a min heap learning. So just understand the code structure. Maybe we will talk about min heap and max heaps even at later point of time in our learning, right? So I'll switch to JS bin. Let's look at the code. So here I have a heap sort, and this is a min heap class. So once we push values, so the bubble up function helps us form the heap pattern. So here, if you see, we are just taking this array and constantly having to uh, build this. We are firstly building this heap and then popping each value out that is at the top, which gives the uh, minimum value in the heap, right? So that would solve the heap sort. So we will understand more on this min heap class, but for now, just understand the idea of min heap and max heap, right? So next I will quickly move to counting sort. Let's take an example, something like 4, 2, 2, 8, 3, 3, 1. Consider this as an array. So in counting sort, unlike bubble sort or any comparative sorting algorithms, merge sort, quick sort, or even the last one that we saw with heap sort, what was this one? So the shell sort, which was similar to insertion sort. So counting sort, unlike the other comparative algorithms, checks for a maximum value in this array. So max value. So what this does is create an array of elements 0, 1, 2, 3, 4, 5, 6, 7, 8, and put the count of all of these values. So now at 0, we see if there is any occurrence of index value 0 in this array. So 0, 0 occurs 0 times, and we see if 1 occurs any number of times, 1 time. So similarly, 2 occurs 2 times, 3, 3 occurs 2 times, 4 occurs 1, 5 doesn't occur, 6 doesn't occur, 7 and 8 occurs 1 time. So then we go about result, which would be like iterate through this array and return the number of times that each index occurs. So 1 occurs 1 time, we write 1 time. So 2 occurs 2 times, 2, 2. 3 occurs 2 times, 3, 3. And 4 occurs 1 time. And 5 occurs 0, 0 times, or 8 occurs 1 time. So which is 8. So this would be the resulting array of this one, right? So let's quickly look at the implementation of this solution. I will switch to JS bin. So here we have uh, calculated the max value and created the count array, which is nothing but uh, this one in our drawing board. This is count array, and once we have the count array, we update the values of the input array to the number of counts at index, and finally we also return the result by moving through the count array with respect to the max array that we created, and we populate the results at each index, right? So that's the whole idea. So if you see the time complexity of count array is often we need extra space, that's for sure. And yeah, in in case of count array, it is a stable sorting algorithm. And is it an in place sorting algorithm? No, right? So yeah, that's about counting sort. And counting sort also belongs to linear sorting algorithms. We will also look at bucket and radix sort, right? So let's quickly switch to the other algorithm, which is bucket sort. Okay, so let's consider an example, something like 0.78, 0.17, 0.39, 0.26, 0.72, 0.94, 0.21, 0.12, right? So 0.94, 0.21, 0.12. So in bucket sort, there is another similar idea to counting sort. We create bucket of 10, bucket of 0 to 10, 0 to 10, uh, 1, 2, 3, 4, 5, 6, buckets of 10, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So here if you see, this sits under a bucket of 0.78 and 0.17 and 0. Yeah, so those are ones, and 0.26 sits here, and 0.72, 0.72. Yeah, these are done. 0.39, 0.39, 0.26, 0.72, 0.94. Yeah, 0.94, 0.94, and 0.21. So these are all the values that are in. These are all the values that would be in a bucket. So next, once we have these values, these buckets need to be sorted. This to lead uh, 0.21 and 0.26, and similarly here it should be sorted to 0.72 and 78. So that's the whole idea with bucket sort. Each individual buckets are also smaller in size, so they can be easily sorted out. So yeah, that's the whole idea. Let me quickly switch to JSBin without much explanation on this one. So here is the bucket sort. So we are creating a bucket uh, range, and we are okay. So we are, as you see, we have buckets 0, 1, 1, 7. Okay, so we have so we are considering the maximum and minimum value in the array, and then we are also having this range. So we are inserting all the values into the bucket at index with value of the array, like the ones that sit in the array. Like for example, these are two that already sit in the array. So and these two are the next set of buckets, and these are next set of values, and these are 0.72 and 0.78. Yeah, so only thing that we need to understand is there are buckets created with empty array like this, and it would be like a count of the array, and we are having to create add in these values at these bucket indexes, specific. So let me simplify this uh, code here. So if I could simplify that piece of code, so the thing that is happening here, in order for us to understand, we are creating buckets with the array of length, and we are also adding uh, the value to the index. Like for example, point 1 sits in the bucket of 0.1, so something like that. So what is happening here is range is max to min. So in case of here, max value is of 0.12 and 94. So it might sit in a bucket of 0 like we see here, or bucket 1, and it is divided with range and multiplied by bucket count, just so that it is optimally allocated to buckets, right? That's one thing to understand here, but understand the key idea like we drew out in drawing board. So that's the whole idea, and then again it is sorted at each bucket, and then all the values are returned to give us a sorted value of the input array. Okay, so next would be radix sort. Radix sort, um, the key idea in radix sort is the numbers and their digits are considered by digit position, rightmost to the leftmost. So let's say if a number is small, like this one we see here, it would be at the lowest position, and a two digit number like 24, which has 10th position in it, 1th and 10th position in it, it would be having uh, 2, which is the lowest one, sits here, and 4, which is greater than 2, comes next, and 7, which is greater than 4 or 2, comes at after this one, and there is 6 also which comes here. So that's the key idea in radix sort. uh, I will quickly move to drawing board, and let me uh, draw out an approach on this one as well, right? So in case of radix sort, okay, let me open a new page. Okay, so in case of the last one, radix sort. So let's say we have 170, 66, 44, 24, and let's say 2, and let's say we have few other numbers here. So the way that this gets sorted is, so it gets to see the digit. This has one digit, and this has two digit, and three digits. So first thing that this takes is the one digit comes here, and the one that have two digits in them, like these values, they check with these value, the leftmost value. 24 is the lowest one, 44 and 64, and then goes 170, which is the three digit value. So that's the way that radix sort works. We will switch again to the JS bin. So here in JS bin, uh, we can see the code for this one. Okay, so here in JSPin editor, we can see the code. So we have, uh, let's say we have an expression 1, and we consider the max value and start with expression 1, and we count by digits gives us what uh, value that is it of 1 digit, 2 digits, or 100 digit, or 1000 digit, or so on. So this function helps in doing that, and once we have that, we get the array, and then we again have the expression multiplied by 10, increasing the number of digit count, and then we place them accordingly. At each time, we also uh, compare the values from leftmost to rightmost. So that is also done in this piece of code, right? So yeah, go through this code snippets. I will paste it in the GitHub link to this video. Please do let me know if you find any doubts or clarifications in this code snippets. We can have a discussion in a comment section. I will stop this video for now. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.